So, uh, the takeaways that I expect to give you from this talk is definitely what is data drift, what are its common types, how it's detected, a very small piece of Python code that I just put together to see that how drift would look and how it can be detected with very basic tests. And then, okay, drift happened and your team got it. What to do about it? And also because language models, they are the talk of the town, so then what does drift look like for unstructured data like text? First of all, a little about myself. I'm leading the research at Centus Inc. And why I'm here to talk about data drift is that for past more than 1 year, I have been working with MLOps and LLMOps. And I've been interacting with many practitioners in industry and our potential clients. They have a lot of concerns. And I see that data drift is one of the most common concerns that we have been seeing. And it is still one of the major causes for silent failure of models. I would be open to collaboration, discussion. Like you can block my calendar and we can talk over a coffee online. So feel free to connect on LinkedIn and Twitter. So hopping on to quickly, why models fail, and I'm sure you must have seen at least one of these four major categories. First is definitely data, and I'm so tired of the saying that garbage in, garbage out, but it is the truth. So any changes in data collection or pre-processing, or if something gets missed out, that can cause issues. Then the model itself is the one that can introduce errors, or it might not be, or you might not have been able to translate your business objectives to the model performance. So again, this is one issue. I've also seen that there is a little less understanding about how models need to be validated or what kind of performance metrics need to be used. So all these, they come under the model issue umbrella. Then definitely drifts. Again, I've just written data drift, concept drift, but there are many, like covariate also, so it's there. Lastly, regulatory. So your models are talking with people and they should not be favoring a particular class when making decisions. So again, bias, fairness, non-compliance when it comes to privacy and transparency. Those are also some factors that can throw off your model. But for now and for this talk, let's focus on data drift. So what exactly is data drift? There is a data set that you use to train your model. You validate it with another set and you test it out, and off it goes. It is deployed. So while your model is sitting behind a service and users are interacting with it, people change, their behavior changes, or it might be that the data that's coming in, its distribution can change. So I've thrown in a bit of maths here, the joint probability distribution for the model behavior and how it would look based on the relationship between the input X and input Y. So what is data drift? Data drift is commonly when the probability distribution of input changes with time. So what the model had known during its training and testing phase, that it is no longer, no longer holds, or model is no longer able to identify the distribution that is now coming from the live data. And there's another kind of data drift that's called a label shift. So over here, the distribution of output changes, but the difference from concept drift is that the relationship between the input and output remains the same. So, for instance, let's take a study of bird population in a city. So with weather, it can change. So while the distribution of the count of birds that is being predicted, it might change with seasonal shift. But then the relationship will remain same. That in spring there would be more birds, and in winters there would be lesser birds. So over here we are seeing a label shift. If I come on to a more serious topic, if we talk about drug tests, so we have certain age groups, and if we are predicting what is the probability of getting breast cancer. So unfortunately, females who are above 40, they are more prone to getting breast cancer. So there is a relationship between these age classes and the output of a positive prognosis. So then, suppose a drug is being tested, and now people are seeing better change in the disease. So the number is coming down for the disease detection, that okay, the breast cancer prognosis, it's going down. So your output distribution is changing, but again, the relationship between the age bracket and the breast cancer probability, it remains the same. So this is called label shift. So why does it happen? It can happen, like I and my team have primarily identified four major factors. First is definitely it could be a bug or some oversight on data quality, or maybe more noises coming in now when the model is facing the live environment. There could be a feature change. For instance, if the age had been recorded in months, and now it is decided that let's collect age in terms of year. So again, there's a major shift in the distribution of the values that we see. Then upstream process changes. These can be as simple as publishing your service to different geography or different demography. So again, your service, it would see a difference in user behavior and the patterns, which might lead to a change in the distribution of the incoming data. And the model that is sitting behind the service, it was used to some other behavior or other patterns, and now it's seeing a difference. And fourthly, definitely time, because training data, it can become obsolete. So let's take a sales portal, and if it has been trained on data that was maybe a year or 2 years old, then it would no longer be relevant if we talk about now. So definitely drift does happen. It is not inevitable. It is inevitable, sorry. And it's just that data drift is there, but when to call it a violation or when to call it an alarming situation. This is where the definition comes in. So I would say catch them young. There are certain tests that are there to see that okay, the distribution is shifting. So how can we detect it early on? So a point that I missed here is that there are four types of drifts. One is it is gradual, it happens slowly, and then there are sudden shifts, very sudden. You will see a very sharp rise or sharp fall in the distribution. Then there's incremental one, where the new distribution very slowly it takes over the original shift. So you would see original distribution, then a bit of new distribution, then original, then more of new, and slowly, the new distribution takes over. And lastly is seasonal. So as I'm talking about birds and maybe shopping behavior, for instance, like Thanksgiving, Christmas, it can see a drastic shift. So this is a seasonal shift. So again, coming back to how we detect shifts, sometimes it's very simple that you can look into the statistics and maybe see quantize or see the skewness of the data or its variance median, that how it was for particular time frame for 3 months, for 6 months, and then compare it to your current live incoming data. Then two sample tests are very popular among industry, and my team has also been implementing them. So it is very simple from the name, two samples. So we have if we come down to statistics, we have two populations, we draw samples, and we just check that whether the two distributions, whether they agree, whether there's a similarity between them. And we use certain confidence with that hypothesis. So same happens here, just that the two samples are, one is from the training data set and the other sample is from the live data. And we just run these tests to see that, okay, the null hypothesis is that these two samples are coming from the same kind of distribution. And if the p-value or it does not agree, then we say that, okay, there has been a change, there has been a drift. And it's not always p-value, it can also be divergence value when we are talking about Jensen channel. And again, KL divergence is also there. And then we have earth movers distance as well. So there are numerous metrics that you can use. So how is it decided? I'll cover in coming slides. While I was talking about the sample test, they work for very well for data that is not too large dimension. If we come down to large dimension data set, then I've seen personally, like some of potential clients have also mentioned, that rather than getting alerted on each and every feature, it would be so annoying for them. So instead of that, they would rather have a percentage share of features. So for instance, if they have 400 features So they might just specify that, okay, alert us if 20% of all features, they show a drift of 30%. So uh, 50 features drifting, or 100 features drifting. So now we are putting a count to it. We're not saying that look for each individual feature. Since it's a large dimension data, go for a percentage share and just raise an alert that, okay, there's a drift if a particular share has seen drift. So this is a small part of logic that my team is using for data drift detection. This is just a small part that when we use what, if it's numerical data, numerical feature, sorry, then what kind of test we would use. And again, the cardinality, or you can say the number of unique values in the set, it plays a significant role when you're going for the test. So let's take the second point that if it's a categorical feature, and it could be something simple like if the survey takes it as gender, so male, female, other, because people tend to club it. So then it's a very small cardinality. Whereas if we go forward with race, again, it can be a large number, or it could be age itself also, it can be greater than 5 if we take age brackets. So then the preferred test, that we can move on to another kind of test. If it's lesser than 5, then go for chi-squared. So I also put together a very small piece of code to show that how, sorry. So I will be sharing the link for this notebook so that you guys can also try. And I put the link for the data set also that I used, Dow Jones one. And I focused on price, which is a numerical feature, and it holds it holds large number of values, large number of unique values. So just a brief view of what the data set looks like. And I've already run it, so I will not run again just in case run into some error. So this is how I simulated the drift. You can pick this function for your own testing. Uh, so how drift is being introduced is from, like, we have taken a last 1 year of data from the data set and introduced the drift in the middle. So there is the position of the data and the magnitude. So zero point 0.5 is, it means that start from the middle of the data set, that's under focus. And size is like go 100%, go wide. So you can change this, you can change it to 0.2, 0.4, and zero point 0.5 as per your choice. So drift was introduced. So this is what the drift looked like while the original distribution was like this. So coming down to the test, I used a very simple test, the earth movers distance or versus distance. And as you can see, it's giving a very large value. So I had created a copy, and in one I had introduced the drift, the other is the original one. And it's very high value because we have seen values up to 1.5, 1.75, which is a decent comparison between two samples from similar distribution. So it definitely says that, okay, there is a huge difference, and if it is this huge value, then definitely something's wrong. So you can put a check on this, you can put alert on this, and no, not okay. Anything above 1.75, or at max, if you want to go till 10 or 15, that's fine. But anything above that, raise an alarm. I also showed one example for KS test. Again, KS test, it assumes normal distribution, which we are not seeing here, and that's why I didn't give the good results. Just to show you that it won't work in this case. I have also added a link to a very nice article by Evidently, where they have compared 5 different kinds of tests for data drift detection. Okay, I'll just okay. So once you have detected data drift, then what? what can your team do? So one does not simply hit the retrain button. That should be a decision after a lot of analysis, and once the decision has to be thoroughly backed by a couple of steps. So first of all, is the data drift a symptom for a bigger problem? So pull out your logs, see if there were any errors there, or definitely you should watch out for data integrity. You should watch out for any outliers or any out of range values. So such data integrity issues can again cause the data drift, and definitely unknown values or outliers. They show that okay, you were not prepared to go beyond a certain range. So definitely look into these problems before hitting the retrain button, or look for the pattern changes. That okay, did the business problem change, did the demography change, geography changed, or like the service, how has its use changed over time. When we were seeing it like 3 months back, it maybe there has been some change in it, maybe it has been floated to a different set of users. So definitely look into those aspects as well. Then read the plots of drifted features. Like I showed a very simple line graph, but you can definitely think of more creative ways to see how the features are drifting uh, on based on different time window values. Also, plotting the correlation of the particular drifted feature with model predictions. That also really helps. While it's very tiny, I put the graph over here just for the context that how number of page views for a website, how the correlation change was pretty significant. Another way you can also do is you can plot heat maps for the singular analysis between the feature and the model prediction. So that can also give you a quick view of how the correlation has changed between the two. And definitely, if you can afford to, you must wait and watch and see if your model is adapting to the drift. So main purpose is to see if your model's performance metric, if it's fluctuating too badly, if it is going down. Then okay, first of all, if it's able to adapt, your performance metric is not going bad. Your model is adapting fine to this change. Congratulations, you built a somewhat robust model. So hydrate and carry on. Otherwise, yes, please hit the retrain button. So a couple of things also. I'm not talking about just retraining with the new set of data, the live data that has been picked up, maybe from last 3 months, 6 months. You can also like if you see that okay, again it is not causing any improvements. Uh, Sometimes teams have to recalibrate the model itself to make it more robust, to make it more adaptable to future drifts. So that is one option. Another thing that we also offer for better analysis or deeper dive into these changing patterns is if you're seeing a couple of features that are drifting a lot, then create a subsegment or a cohort of weekly performing features. Just make this subsegment like if it's a health data set, then you can make a subsegment of maybe females who are between the age of 25 and 30 who have never been pregnant. Make this subsegment and then check out that okay, what's the problem? Maybe the model had not learned enough for that subsegment. It was an overlooked one. So these are deeper issues that are uncovered by drifts. So data drift is definitely it's not a foe. It can actually help in making your model more robust. It can improve its performance, and it can definitely point out mistakes that you did while translating your problem to a machine learning solution. So okay, like text, yes, it's pretty exciting, and I worked a bit with monitoring of NLP models as well. So how does those shift look like? So we have the text coming in, and a lot of problems are done. Like there's summarization or sentiment analysis, Q&A. So what happens is that there are meta features that are associated with your text. While sentiment is one, you can have subjectivity, whether the person is being very factual while writing the text or they are too involved with it. Then text complexity, that is the readability of the text, and presence of auto vocabulary words and the language itself. So these are the meta features of the text that can also vary over time or due to change of the upstream processes. For instance, you have exposed a chat agent. Firstly, it was working in a certain demography in a small space. Now you have expanded your operations, your service is exposed to a larger number of people, people who may not be native English speakers. So again, this change in the properties that can definitely cause a shift, a distribution shift. Then again, I've also seen embeddings drift as well. So the embeddings of the training data versus the embeddings of the live data, they can be compared. That's a very easy way and a very quick visual that you can get of such shifts. And then again, some points where unstructured data changes compared to the numerical and categorical features is that usually it remains same. In English, a cat would remain cat or a set of synonyms, but it would not go off too much. Whereas when you're talking about numbers, yes, they can vary a lot, especially if you're talking about numerical features. They have a bigger space to vary over. Again, do check for integrity issues on outliers. You can look for outliers in terms of the frequency of the languages that your service is seeing, or how is the complexity of the text varying over time. Such outlier checks, they really help in identifying anything and how the incoming data they stand against each other. And again, yeah, did any external factors change or not? So I guess this was it about the talk. And do get in touch if you have any queries. And I guess I'll just open the floor to Q&A.
Awesome. Thank you so much, Gatha. That was phenomenal. I'm looking in the chat now. It doesn't look like there's any questions quite yet. So again, I'm going to open up the stage
Okay.
to all of the audience. If there was anything that's pending or anything that you'd like to get clarified, here's your opportunity in the Q&A. If you drop them, we can go ahead and read them out loud and get you some answers to that.
Okay. Let me just share. Should I share the link of the collab over here only?
Yeah, that would be awesome.
Okay. Let me just send the setting also. Okay, that's the blog post, not the collab.
Still not seeing any pending questions. I guess you did that good of a job. You explained everything so well.
Okay.
There's nothing lingering people.
It might be the other way around. You never know. There might be an absolute polar shift.
I like to think a best case scenario. Did too good of a job.
Thanks. Thanks,
Here
Melissa.
here talk of the examples. It looks like we might have a question. Which libraries do you find most helpful?
Uh, it would be a conflict of interest because we ourselves are developing the solution, and I personally find yes, evidently is pretty good. Nanny ML is also pretty nice. You can check it out.
Got the ball rolling with one. Let's see if we can. Great talk indicated that the drift text data is much.
It's
All right,
much
so this
less
says we
than
got
this.
another one. You indicate that the drift text data is much less than the structured
Okay.
data.
Yeah. Yes. So when I was talking about that drift is less, I meant that the text is much less prone to drift. For like, I give the example that cat, and at max there can be typos in it or synonyms in it. It wouldn't be like that the word would gain another meaning or it would another word would replace cat. So that is one thing. But yes, sentiment can change with time, and therefore watching for drift on sentiment, that is also important because that means that the service maybe it is getting buggy, it is getting laggy, people are not happy, people are starting to abuse. So when I talked about watching over sentiment, it is also important. metadata that's of toxicity and abusive words. So that again, while we are protecting the system, we are putting guardrails or guidance against it, but definitely watching over it as well, so that we see that okay, is there going to be any shift in how much abuse or the abuse or bad words the system was seeing earlier, and with time if it's getting worse. So pretty much analogous to this is the complexity of text that is coming in. Again, that can also be watched, so that your model is not thrown off guard. I hope that answers your question. Right.